Hey everyone, welcome to today's Explainer. We're going to be taking a really close look at the invisible mechanics that literally make our entire universe tick. We're talking about the fundamental fabrics of energy. It's going to be a fun ride, so let's get right into it.
Okay, let's dive into this. Section 1, the mystery of motion, where we'll be investigating everyday energy.
Picture a car just absolutely zooming down the highway, right? It's literally thousands of pounds of metal moving at incredibly high speeds. But think about it. What exactly gives it the power? That ability to do work, to carry all that massive weight from point A to point B. Now let's completely flip that scenario. What about a ball just sitting at the very edge of a tall table? It isn't moving an inch, yet somehow it possesses a hidden reserve of power. How is that possible? Well, the mechanics behind both of these everyday mysteries actually come down to two super important forms of energy, kinetic and potential.
Which brings us to Section 2, Understanding Kinetic Energy, the Power of Movement.
So, what is it? Kinetic energy is simply the energy possessed by an object entirely due to its motion. That is the golden rule right there. If it's moving, and I mean absolutely any moving object, it possesses kinetic energy, period.
So, the crucial point here is speed. Speed is the absolute catalyst. There is a direct, undeniable relationship going on here. As an object's velocity increases, its kinetic energy scales right along with it. It's really that simple. Let's make this a bit more tangible, all right? Kinetic energy really just boils down to two main variables: mass, which we represent with a lowercase m, and velocity, represented by v. Think about that moving car again. It has a massive amount of weight, or mass, and high velocity, so its kinetic energy is off the charts. Now, a flying baseball, it has way less mass, sure, but with a super high velocity, it still packs a major punch. What about flowing water rushing down a riverbed? That's mass and velocity working in perfect harmony. Or even just a running athlete sprinting down a track. That human body in motion is a perfect, real-world vessel of kinetic energy. Ultimately, it all just comes down to the mass of the object and how fast it's moving. Let's move to our next core concept and see how this builds. Section 3, the power of potential, or stored energy waiting to be unleashed. Potential energy is the stored energy an object holds because of its position or its condition. Notice the shift here. This isn't about movement at all. It's entirely about physical placement or a specific state, creating a hidden, silent reserve of power. A huge part of this actually has to do with the planet we live on. Earth has this invisible, constant downward pull, gravity, right? And it acts on stationary objects to give them what we call gravitational potential energy. So if you place an object up high, it suddenly has all this potential power, simply because gravity is just eager to pull it right back down to the ground. Let's break down the variables for potential energy. It depends on mass, the acceleration due to gravity, and height. So m, g, and h. Look at water stored in a huge dam. It's high up, it's incredibly massive, and gravity desperately wants to pull it down. That is a colossal amount of stored energy. Or, take a simple book placed on a high shelf. It's just sitting there, minding its own business, but because of its mass, gravity, and its height off the floor, it has gravitational potential energy. Now, what about condition? Think of stretching a rubber band. You physically changed its condition by pulling it back. It's not moving yet, but it holds incredible potential energy, just waiting for you to let it snap. Now, what's really interesting about this slide is the stark contrast between these two forces. On the left, we have kinetic energy, the energy of active motion, driven entirely by mass and velocity. And over on the right, we've got potential energy, stored energy just waiting silently, dictated by mass, gravity, and height. It's moving energy versus waiting energy. Honestly, it's just a brilliant duality. All right, this is where things get really fun. Section 4, the Great Energy Exchange. We're looking at the law of conservation in action.
This right here is a foundational rule of our universe. Energy can change from one form to another, but the total amount of energy remains completely conserved. It doesn't just, disappear into thin air. It transforms. It constantly hands the baton from potential to kinetic and back again. And this brilliantly illustrates that exact transformation. Think of it like a roller coaster energy dance. Picture it. Step 1. The coaster clicks its way up, up, up to the very top of the highest hill. It pauses for just a split second. Right there, that's maximum potential energy. High mass, gravity pulling down, maximum height. Then step 2, it plunges. As it drops downward, the height decreases, but the speed increases. The potential energy is actively, rapidly changing into kinetic energy. And by step 3, when it hits the absolute bottom of that hill at maximum speed, it has maximum kinetic energy. The total energy was completely conserved the entire time. It just flawlessly converted its stored, waiting potential into zooming kinetic action.
Which brings us to our final stop, Section 5, Why Energy Matters, and bringing it all together.
Look, these aren't just boring textbook definitions. They're essentially the master keys to understanding our entire physical world. Kinetic energy is the energy of motion, driven by mass and velocity. Potential energy is stored energy due to position or condition, mass, gravity, and height. And that energy, it's constantly transforming from one form to another. This incredibly simple concept literally explains the machines in our factories, the cars we drive, the dynamics of the sports we play, and even the massive natural processes of our planet. It all comes back to this one fundamental exchange.
So, as we wrap up, I want to leave you with a question to chew on as you go about your routine today. Look around you. Where will you observe energy transforming in your own life? Maybe it's a pendulum swinging, a basketball dropping on the court, or honestly, even just you getting out of your chair. The physics of motion is literally everywhere, just waiting for you to notice it. Thank you so much for joining me for this explainer. Keep observing and keep learning.